Hello everyone, I am very happy to have you all here today. In this lecture, I will discuss formation of T wave. At the end of this lesson, you should be able to understand the ventricular repolarization, understand the T wave and understand T wave vectors. I am focused to discuss about ventricular repolarization, characteristics of normal T wave vectors and QRS-T angle. Ventricular repolarization. The ventricular repolarization means restoring the polarity of the cell to its original negative potential. This occurs after the contraction of the ventricles. It is recorded as a ST segment and T wave in the ECG. The ventricular repolarization begins on the surface of the epicardium and extends towards the endocardium. Ventricular repolarization occurs opposite direction to the ventricular depolarization. The ventricular repolarization lasts longer than the ventricular depolarization. Notice that T wave is flatter and longer than the QRS complex. The longer duration occurs because conduction of the repolarization wave is slower than the wave of depolarization. T wave. T wave represents repolarization or recovery of ventricles. It is next positive or negative deflection after the ST segment. A normal T wave has an asymmetric shape, that is, its peak is closer to the end of the wave than to the beginning. You all can measure asymmetry of the T wave by drawing a line from peak of the T wave to the baseline. Then measure each side. The asymmetric of the normal T wave contrasts with the symmetric of T waves in certain abnormal conditions. Do you all remember the action potential diagram of the heart muscle cell? So, this is the action potential diagram. It contains phase 0, phase 1, phase 2, phase 3 and phase 4. So here phase 3 is correspond to the T wave in the ECG. During phase 3, the action potential slowly returns to its polarized state, mainly founded on outflow of potassium ions transported from the cell to the extracellular space. The normal T wave is usually concordant with the QRS complex. It means if the QRS complex is positive in a certain lead, the T wave usually positive too. If the T wave is discordant with QRS complex, then it is abnormal. In this diagram, positive area of the QRS complex is greater than the two negative areas. So here net QRS complex is positive. Then T wave should be positive. In here T wave is concordant with the QRS complex. In this diagram, positive area of the QRS complex is smaller than the negative areas of the QRS complex. So, net QRS complex is negative and T wave should be negative. But in here, the T wave is on the other hand. So, this T wave is discordant with the QRS complex. Ventricular repolarization occurs opposite direction to the ventricular depolarization. Ventricular depolarization occurs from endocardium to epicardium. Ventricular repolarization occurs from epicardium to endocardium. So, two different activities occur in the opposite directions. Because of this, the T wave usually points in the same direction as the major components of the QRS complex. Sometimes you might wonder why depolarization and repolarization waves are represented in the same direction. Do you all remember depolarization wave or positive wave travel towards the electrode? It records positive wave. And here the repolarization wave or negative wave travels away from the electrode. It records as a positive wave. As a result, both QRS complex and T wave records in the same direction. T wave vector. This is frontal plane T wave vector. It is directed leftward and inferior. As a result, T waves are always upright in L1, L2 and inverted in AVR. Horizontal plane T wave vector. In the horizontal plane, the T wave vector is directed leftwards and usually anterior. Therefore, the T waves are always upright in left precordial leads. T wave morphology. It is normally upright in L1, L2 and as well as V4 to V6. It is inverted in AVR and may be upright or inverted in L3, AVL, AVF, V1 and V2. T wave is usually smooth. If it is sharp or notch may be due to superimposed P on T wave. The T waves are usually not taller than 5 mm in limb leads and 10 mm in precordial leads. Children may have T wave vector directed more to the left and backwards. This is one of the examples. Inverted T waves can be seen V1, V2, V3 leads. This is a normal finding in children. Due to right ventricle dominance in infants and children, T wave inversions are seen. That is we called juvenile pattern. The right ventricular dominance of the neonate and infants is gradually replaced by left ventricle. However, this juvenile T wave pattern can persist into adolescent and early adulthood. That is we called persistent juvenile T waves. In children and young adults, the orientation may be slightly posterior but becomes increasingly anterior with advancing age. QRST angle. The QRST angle formed by the QRS axis and T wave axis. The angle between QRS axis and T wave axis normally does not exceed 45 degrees. If angle is more than above limits, the ECG is abnormal. In this diagram, QRST angle is 17 degrees. Complete the below exercise. Thank you very much and stay safe.